Okay, so our last section in Module 4 is Section 5, which is more about the graphs of quadratics, which we know are parabolas. So we talked about a vertex, we talked about an axis of symmetry. So new things we're going to talk about are the X and Y intercept. So the Y-intercept simply is going to be the point where the graph crosses the y-axis. Now, it's always where it crosses the y-axis, and where it crosses the y-axis, it's also always the point where x equals 0. Opposite of that is the X-intercept. The X-intercept are the point or points where the graph crosses the x-axis. And again, also on the x-axis, this is always the point where y equals 0. Typically only one y-intercept, but you can have multiple x-intercepts or no x-intercept. So there are two different ways to do this because, again, we have our standard form, which is our ax squared plus bx plus c, and we have our vertex form, which is our y equals a x minus h squared plus k. So if we look at this first one, which is in standard form, we want to graph this quadratic equation using Desmos, and then we want to find some information about it. Okay? So if I look at my Desmos, so I'm going to put in my quadratic, which is y equals x squared minus x minus 6. Just make sure I have that right. So what you get is this quadratic. You see this parabola for this graph. Now, if I move this, I can just pull my screen and move it around. You'll see that here is our vertex, which looks like to be at 0.5 and negative 6.25. And that's, again, getting our negative b over 2a. But the things that are interesting in this section is we have this point where it crosses the y-axis, which is 0, negative 6. And this one has two x-intercepts, which happen to be very nice. They don't have to be very nice, but in these cases, they really are. We have negative 2, 0, and we have 3, 0. So two x-intercepts, one y-intercept, and one vertex. So now we have the graph. We can answer a lot of these questions. What is the y-intercept graphically? Well, it was, of course, 0, negative 6. And we just got that right from the graph. Where can you find the y-intercept in standard form? So if I look at this equation, where do I see a negative 6? Well, if you notice, in standard form, it is the last number. It is always c. So in standard form, the y-intercept is always c. Okay, x-intercepts graphically, we certainly can have. There were two of them. They were negative 2, 0, and 3, 0. Now, finding these algebraically, we can do as well, because if you remember, we said that the x-intercept is where y equals 0. So if I look at this equation here, if I just make y equal to 0 and solve it, I should get these intercepts. So if I do 0 equals to x squared minus x minus 6, if I solve this, I should get negative 2 and 3. Now, this is a quadratic, which we can solve lots of different ways. We can do our quadratic formula. We can do complete the square. I'm just going to factor it because this is actually a pretty easy one to factor. You could use your rectangle factoring, but this will factor as x minus 3 and x plus 2. So if I solve each of those individually, so 0 equals x minus 3 as my first one, and then my other one would be 0 equals x plus 2. So you'll notice if I solve these, I get x equals 3 for the first one and negative 2 for the second one. So that was the exact same thing I got when I looked at my graph. So the x-intercepts you can definitely do with, quadratic formula, or factoring, or completing the square, or whatever one you want to do. Okay, let's look at one more example, and this is of a quadratic in vertex form. Let's take this to the next page. So in vertex form, remember we automatically know the vertex. It would be the opposite of this, so 2 and then 9. So right away I know the vertex is 2, 9. So we can verify that by graphing this. So let's go over here. Y equals x, just clear this out. Y equals x minus 2 squared plus 9. So I don't really see my graph, but I know my vertex is way up here. So if I take it all the way up here, I could find some of this information. So there's the vertex. This crosses the y-axis at 13. So it does not cross the x-axis. As you look, here's the x-axis way down here. This parabola is up here. If I were to change it, like if there was a negative sign in front of it, it certainly would cross the x-axis. But in this case, it does not. So the y-intercept was 0, 13. Now, I don't see 13 up here. But if I wanted to find it algebraically, we could, because remember, the y-intercept is always where x equals 0. So if I set x equal to 0, I would get y equals negative 2 squared plus 9. So if I set y equal to 0, or x equal to 0, pardon me, I get y equals negative 2 squared plus 9. Well, negative 2 squared is 4. 4 plus 9 is 13, so y equals 13. So in standard form, much easier because it's just c, but in this case, not. What were the x-intercepts graphically? Well, that was easy as well because remember there were no x-intercepts. Because it went up, the vertex was above the axis and it went up. Now, could you find these algebraically? You absolutely could. We just do it the same way as we always do. We would set y equal to 0 because x-intercepts are always where y equals 0. But if I do that, I'll get 0 equals x minus 2 squared plus 9. So the easiest way to solve this one is since it already has it in square form, I'll subtract 9 from both sides. So I'll get negative 9 equals x plus or x minus 2 squared. And then to get rid of the square, I'll take the square root. But when I take the square root of negative 9, remember I get 3i. So 3i equals x minus 2. So my solutions are going to be x equals 2 plus or minus 3i. Well, imaginary numbers cannot be on the axis. So we would just say since imaginary solutions there are no x-intercepts. Obviously, looking at the graph is a much easier way to do these kind of problems, but you can see the algebra and the techniques we've learned can help us find those as well.